on, baby. Come on, baby. Come on, baby.
$100 later.
What's up, man? No. There's no one driving that car.
Yeah, it's a smart car.
Yeah, I can see that.
No, it's a smart car. It's self-driving.
What? That's awesome.
Yeah, so, and I guess the question is, how have we gotten here? How have we gotten ourselves to these things like self-driving cars? And it's really interesting. And at the United States Naval Academy and the Weapons, Robotics, and Controls Engineering Department, we take a class called EW456, Autonomous Vehicles, that really gets to the core of these ideas. Therefore, myself, Midshipman First Class Brendan Pelletier, my partners, Midshipman First Class Ivette Ayala and Midshipman First Class Nate Harding, have developed a final project to demonstrate our knowledge and everything we've learned throughout the course. And we would like to show you the results. So let's do it. So we used the Create 3 robot and we were operating out of Hopper 208. And the first thing we did was create an occupancy map to visualize the free space in the room. So it was a map where all the free space was in white and all the occupied space is in black, because previously we learned waypoint controllers, but if we want to be more efficient, we learned things like pure pursuit controllers, but that would be hard to implement if we just said go from point A to point B if chairs or tables or obstacles are in the way. So we need to have a step before that allows the robot to think on its own to avoid obstacles and still implement our pure pursuit controller. So we did an RRT path planner, which starts at a root location, which was in the center of the room, that we used for all the central locations for all our reference transformations. And from that root location, it would pick a random point in space and then find all the available nodes due to our max connection distance. And then it would run the path. It would ask itself, did it hit anything? If no, was it successful? If successful, then it would add to the tree of possible paths. So when it comes in contact with an object, it can add to the bank of solutions. And then we had to make a longer max connection distance because the shorter one made the robot driving very choppy, because if you're always looking over your back, you're not really going to get anywhere. And then we had the ability to put locations of objects pre-placed in our path by using the motion caption system in the room. We were able to find the mocap coordinates of these objects and then put them on our occupancy grid that initially weren't there, and we could specialize for our specific path. And then we implemented a pure pursuit controller that once the RRT path planner found us a successful path, the pursuit controller executed perfectly. Our biggest challenges are listed on the screen. So our reference frames are not something we got right on the first try. We struggle with that. We know the right way to do it, but it comes with a lot of trial and error. And incorrect rotation matrices in various parts of the controller have a large effect on the robots accurately, because you think you're implementing correctly, but it's not doing what you want, and finding that error was very challenging. And lastly, the ability to calculate the angle of the robot in real time as it moved was another challenge we faced, but ultimately we were able to overcome it, as I'm going to show in our final video. Let's go.
Sorry.